Anybody not registered? Do you want in? Okay, there are sign-ups up front. You're welcome to do that. You don't have to do it right now. You can do it after class if you like. All of these are equivalent. You don't have priority depending on which of the three are identical. We have room in the lecture, as you can see. This is because it's a terrible class and nobody wants to take it. But actually, I think the primary reason is because of labs in the university. I shouldn't say this while I'm recording. They won't give us enough money for the labs. So we are expanding this course, and the lab has been somewhat small in numbers. And so what we're doing is just trying to increase that. So if you need the course and don't need the lecture, come on in. All right, sign up here. Otherwise, keep an eye on Connect Carolina. And as you see the lectures, if they drop below 24, send me an email and say, hey, I'd like in this lab, and we'll get you enrolled. Okay. So if you need just the lecture, I can get you in, no problem. Okay. Tell your friends. If you need in the lab, keep an eye on Connect Carolina. Okay. This really bothers me. It's off center, and I don't know why it's highlighted in green, but this will look different next time I'm having technical difficulties. It's not my fault. What we're going to be doing in this course is we're going to be talking about anatomy and physiology. And the reason behind this course, why this course exists, has largely to do with a student-led protest isn't the right word. But you got people leaving already. Students were interested in having a second semester of anatomy and physiology. Okay, now I'm hurt. Try to push on. Most of you, I think, are pre-PA, or at least maybe half of you. How many of you are pre-PA? Yeah, okay. You need this course. So we have intended, Dr. Sheber and I and Dr. Garland, in Biology 252, to be comprehensive of most things that you need, because most schools don't really require 2 semesters, but when it comes to PA schools, they do. So we're kind of left with a conundrum in this course. What do we talk about since we've covered everything? Well, it turns out we haven't covered absolutely everything. And what I've chosen to do in this course is to the best of my ability, prepare you for the next level of school, which is in many of your cases PA school, but for a lot of you it's medical school or some other professional school in health sciences. And what that means is primarily not more anatomy like you learned about, particularly in the lab 252, naming muscles and bones and so on. But most of you are going to need a much better grasp on physiology. So that said, title of the course is Advanced Anatomy and Physiology. Mostly what we're talking about is physiology in this course. Okay? So if you feel like you're not getting enough anatomy, that's the reason. Okay? It's because the physiology is something that requires a little bit more at this level to help prepare you to move on to the next stage. Okay? So that's the reason behind it, and who it is designed for. We're really, the department is really trying to offer something that's ideal for a pre-PA and pre-medical student. Okay. I had a pull everywhere that many of you have looked into. I'm gonna figure this thing out here. And if you haven't yet gotten into pull everywhere, here's the address at the top. And you'll find that this is the address that it's always going to be. I've got 102 of you, and I think there are 120 something on the roster. So if you haven't gotten in yet, go through Sakai and make sure that you have gone through the procedure of linking yourself up to Pull Everywhere if you haven't done so. If you've already done so in a previous class, you should just be able to go into that address and it should work. Okay. These are the most common careers, with the exception of college professor. I just put that up for me. And you're welcome to add here. I'm going to assume these changes that are happening are because people are not changing their minds already. All right, so you can see that, and this helps you, I think, realize that most of your classmates are pre-PA, okay, and pre-ND physicians over there. Who picked college professor? Nobody? It's a joke. So last year, there was one person who did, and then it turned out it was a mistake. They hit the wrong button. It was really sad. But I hope you realize who your peers are here. That said, I don't want you to be in competition with one another. I know there's sort of a tendency for people to think that way. None of my course policies pit you against one another. I don't curve anything. Okay, so your performance depends on you, doesn't depend on other people. Okay, so I'm not going to be curving at the end. If you all get A's, that's fine with me. Okay, you won't all get A's, but if you all got A's, there would be no penalty for that. So if you haven't yet already, go ahead and get in here and check out Pull Everywhere. There's a link on Sakai. Okay. We're going to be using Pull Everywhere most every day in this course. I sent out an email about not sitting in the first 12 rows. How many of you got that? Yeah, okay. It turns out there's only like 14 rows. I thought there were more rows here. But as much as you can, try to sit a little bit towards the front. If you want to sit in the back, that's good. That's fine. That's fine. Hey, up there. But especially if you're not going to be participating, if you're going to do some shopping, or do anything that would otherwise be distracting to people sitting next to you, sit in the back. Okay. I don't mind it. But I would really prefer, as much as possible, you can be close with everybody else. So I've already told you we're going to be focusing on physiology in this course, or mostly physiology. We'll talk a little bit about anatomy, kind of name parts, right? And we're going to talk a little bit about histology, okay? But largely physiology. And these are the systems that you, as you move on to PA school or medical school or wherever you're headed, these are the systems that you're probably going to encounter the most trouble with and will encounter the most often, okay? And so, like I said, I want to help you guys with regard to understanding these systems. So, that's what we're going to be covering. We are going to be teaching this from the standpoint of you all being future clinicians. Okay, so you're going to be learning about things that are important to you, obviously, but also within the context of someone who's a healthcare provider, not so much that you're going to go on and become a PhD in biology. Okay, the focus would be a little bit different. Okay, we're going to do lots of problem solving in this course. And I will, throughout the course of the lecture, ask a lot of questions. Some of these will be Pull Everywhere, but a lot of it is just sort of conversational, and I expect that if you want to get the most out of the questions that are being asked, being posed to you, that you try to answer them. Okay, this is how we learn. Okay, so a couple of things I want to mention before we jump into today's lecture is that you've got a syllabus. I'm not going to spend the first day of class reading through your syllabus. Okay? Anybody disappointed by that? Nope. I didn't think so. I record lectures. Okay? So occasionally, I know I'm a lot older than you, but I'm not technologically adept. Okay? Occasionally, there are technical problems and my recordings disappear into the ether. Okay? So if you're somebody who thinks they might rely on the recordings, make your own recording, right? And feel free to make your own recording, and probably 99% of the time you won't need it. But in the event that you do need it and my recording goes away, you'll have something. What I'll do is I will be recording both my audio, also the whatever's here on the slide projector. Okay. So whatever's being projected here will appear along with my voice, and you'll have a link that will be on Sakai. Okay. So I'll put it right alongside the PowerPoint for the day. Okay. So you'll see that sometime same day. Okay. If you don't see it the same day, send me an email and bother me. Okay. Happy to be reminded about that because I have to do something to sit up here. Okay. What else can I tell you? The exams. There's going to be some exams. They will be mostly multiple choice. Okay. And you may find an essay question or two at the bottom, the last end of it. Each exam will have some material from the previous unit, so exam 2 will have a little bit from material 1. Okay, I'll give you a heads up about what that's going to be generally, so you're not having to study with the same excruciating detail. Okay, so you get a little bit of a heads up about what to expect in terms of the cumulative carryover. Okay, I know cumulative exams are scary, so I'm going to kind of help lead you through that. Okay. But mostly multiple choice. Actually, I think I've got this on the next slide. With regard to the reading is expected prior to class. I don't expect mastery of the material, but I do expect that you will have read. And in particular, what I'm hoping you get out of the readings is these bullet points here. Okay? I want you to have the vocabulary before you come into class. Okay? So if we're talking about oligodendrocytes, no, we're not going to talk about this in this class. But if I say the word oligodendrocyte, you will have seen that. You're not going to be distracted by how many syllables it had or anything like that. And we'll talk about the context of that subject, whatever it happens to be. But I don't want you to be stumbling over words for the first time. So this is part of what the reading provides. Okay. And then the subject matter, right? I obviously want you to understand it. Okay. I don't expect that you will have mastered it, otherwise there'd be no point in coming to class, right? And we'll go a little bit further than the book in some cases, okay? In many cases, and we'll add things to what you're supposed to know. Okay, so the book is there as a foundation, and most of what you need to know is in the book. We'll go a little bit further at times. Okay, and probably most importantly, if the things that you don't understand, this is your chance to alert yourself. Okay, go through here and say, I remember in 252 we talked about this. I don't quite get it, and I still don't get it. Okay, make a note of that. Come into class. When we get there, raise your hand and say, explain this crazy thing. I don't get it. Okay, and I'm happy to do that. I'm happy to go through and provide a little bit more background, if it's background or if it's a completely new topic. Stop me at any point. Okay, your readings can be found in the syllabus. If you want to find the syllabus in Sakai, it's also on Connect itself. You'll have the readings listed there. So for today, you can see the number on the left, it says 01. That's the first lecture, okay? So this is the readings for today. And in order to get your credit for doing that, there are some questions that'll pop up, and there's some links in Sakai to help walk you through that process if that's not clear to you. So after you've been through Sakai and you still don't get what you're supposed to do in Connect, send me an email, come see me, whichever, okay? Okay, but you'll find the readings there. Okay, so most days it's not a huge amount of reading. It's a little bit technical, but you'll get through it. Okay, so then you come to class and we're going to be talking about the subject. Okay, simple enough? Okay. Reading, exams. There's some quizzes. There's some quizzes that'll appear on Connect, and those are sort of further practice for you. They are going to be open book, right? So it's not that you have to memorize everything going into those, but I think if you treat it like a run through for the exam, you'll get a lot more out of it. Okay, you get to do those quizzes twice. Okay, we'll take you back grade. So when it comes to your course grade, you're going to have exams, you'll have your reading homework, and you'll have these quizzes. Okay. And the percentages are all listed on the Sakai on the syllabus. So with that, any questions about what's happening here? Anyone else want to leave? Yeah.
Are you supposed to be exam dates for the other exams, like other exam time?
The other exam dates are on the syllabus. I've only put, yeah, are they not there?
There.
They're on the syllabus. They're not in Connect yet. So Connect, I've only put, I think, the first unit up to the first exam. And then I'm just trying to not clutter things for you. But that's me, I don't care for clutter. Yeah.
I know this is kind of far in advance. For the cumulative final, is it like what you said, there'll be a little bit from 1 and 2? Or is it gonna be like overall cumulative?
Oh, for the final, you'll have material from the previous exams, but it'll be far and away primarily based on the last unit of material. Yes?
On the syllabus, you mentioned a link for getting readings for the lab. I couldn't find that link.
Okay, okay, let me check that after class. If you wouldn't come up and remind me. You're talking about the lab.
Yeah,
Okay.
the readings for the lab.
Okay. I have a typo. I'm not exactly sure what you're talking about. We'll take a look right after class. Okay. For those of you who are in the lab, lab's gonna be fun. You'll like it. It's great. It's not at all like 252 lab. If that wasn't your favorite, lots of cool stuff that you'll be doing there. Working in groups. There's no models whatsoever. It's great. Okay. Two other things to mention. We do have SI session set up for this course, and we do have a peer mentor for this course. SI sessions will be led, the first one is going to be next Wednesday, is that right? Next Wednesday, 6 p.m. And our two SI instructors are in the back. If you want to stand up there, both of you. Okay, I just picked these people at random to lead SI sessions for you. Actually, they're incredibly great students from last year. If you guys want to say hi. Hey.
I'm Lauren. I'm 3PA, so I can relate to all 50% up there, yes.
Yeah, my name's John. I am not 3PA. I actually took this class for fun, not as a requirement. But yeah, it's pretty sweet. If you love physiology, like especially kidneys, you'll enjoy it.
I'm doing this for fun too. I don't know if you know that. I do get paid, but I do it for free. I've got the best job. Where's is Carolyn Schroeder here? No. Okay. You have a peer mentor as well, and instead of the SI sessions, which will be kind of recapping the lecture topics and a bit of Q&A, the peer mentor is going to be, I don't have the dates off the top of my head, but she's going to be leading. Not so much sessions, but doing more one-on-one kind of work, or if you want to meet as a group of 2 or 4 people, whichever. But she'll meet by appointment, and she'll offer some more individualized attention. Okay. Whereas SI is going to be a little bit more group-oriented. Okay. So lots of resources, lots of help in this course. So with that, any other questions about what's going on here? Okay, let's jump into it. So. We're going to be talking today and for the next couple of lectures about things that are, in a way, related to this boundary of the cell membrane. So we're not going to spend a whole lot of time talking about the membrane, but really things that relate to it, like diffusion and osmosis and membrane potentials. And even when we jump into the heart very early on in the course, a lot of this has to do with the membranes of these cells. Okay. So one of the first things I want to talk about then is an overview of the membrane. We're all on the same page. I think, is anybody here taking biochemistry? A few of you? Me? Yeah, small number of you. Okay, so take a nap for a little bit. But we're gonna, for the rest of you, we're gonna go through this in just overview some of the things that I think are important for you to remember. And I think most of you have learned this before. I just want to make sure we're all kind of on the same page, okay? So we have a phospholipid bilayer, remember this? And what are phospholipids? There's 2 little tails, right? What are those made of? Anybody? Fatty acids, okay? And they're hydrophobic, right? And then there's a hydrophilic head on them, okay? And so they organize into this bilayer. So all the hydrophobic parts are buried in the middle of the sandwich, and then you have the hydrophilic, the water-loving parts on the outside, okay? So it creates a layer of lipids that have very important properties biologically, okay? So in addition to this phospholipid bilayer, buried within that is cholesterol, okay? Now, cholesterol is not a bad thing. We love cholesterol. Cholesterol is really, really important, and it is a structural component of our cell membranes. If you have high LDL cholesterol, yeah, that's associated with high incidence of atherosclerosis and heart attacks, bad stuff, okay? But cholesterol as a molecule is an incredibly important thing. Our cells synthesize cholesterol, and does anybody know what its important role is in this membrane? Yeah.
Fluidity.
Yeah, it adds fluidity to the membrane. Okay? Without it, the membranes would be a little bit more rigid. This allows a little bit of space between those fatty acid molecules, and the membrane becomes a bit more fluid. Okay, very important. But together, the phospholipids and the cholesterol make up a lipid barrier that prevents a lot of molecules from passing through the cell membrane. Okay. The other thing that's here are proteins. Okay, and the proteins are present in pretty large numbers. There's about 1 protein for every 50 phospholipids. Okay, so they're pretty numerous. Phospholipids are much smaller. And what are these proteins involved with? What do you remember from your previous coursework? What are some of the roles of proteins in the cell membrane? Yeah. Yeah, they're involved. Some of them are receptors, and they participate in signaling from outside the cell to inside the cell. Yeah. Yeah. Transport. Yeah. So they themselves transport molecules through. Some of them form channels that allow things to pass through. Right. Many of them have immunological function. Okay. So there's lots of things that these proteins can do. Okay. So together we've got a membrane that is mostly, in terms of the structure that you see and its physical properties, most of that is due to the lipid bilayer. The proteins have some special functions along the way that really help define the role of those particular cells. Okay. So I want to talk a moment about diffusion, and it seems like a really basic concept that a lot of you have learned about, but I want to go a little bit in depth and make sure that we're all on the same page. When it comes to physiology, diffusion, such a basic process, is responsible for so many phenomena that we can explain. Okay, so it's important that we have a good grasp of what's going on here. So briefly, if we've got a little setup like this, a hypothetical scenario where we have 2 fluid chambers separated by a membrane, okay? That membrane allows the substance to go from one side to the other. Okay, our little molecule of glucose here in purple has a predictable behavior, okay? So at time A, we've got all of our glucose molecules on the left side in chamber 1, nothing in chamber 2, okay? What's happening at time B? Yeah. Yeah, we see some of those molecules from chamber 1 moving into chamber 2 from high concentration to low concentration. Okay, so this is the basic property of diffusion, that molecules move from a high concentration to a lower concentration. Okay, very, very simple stuff. Okay, what's happening at C? Right, there is an equal flow happening in either direction. Okay, so in times A and B, well, so in time B we have a net movement from 1 to 2. In time C up here, there is an equal amount of flux, equal amount of movement across that membrane. Okay, and we say that it's in a state of equilibrium, which is not a state of stasis or lack of anything happening, but it's a state of equal flux across that membrane. Okay, so I want to show this graphically, and we're going to do a lot of interpretation of little graphs like this. And here we have our two compartments. We have compartment 1 and compartment 2. And we have some molecules moving, a molecule moving. Okay? And I want you to go through these questions with someone close to you. And wait, before you do that, by the way, introduce yourself. Say something, so we could do some really fun ice. If anybody says the word icebreaker, I tend to leave the room. I do this in faculty meetings. Like, oh, we're gonna talk in groups. I gotta go. I do really, but you can't. Tell me what's happening here, and in particular, we've already kind of talked about 1, but number 2 is very important to conceptualize. I want you to take a look at number 2 and number 3 here. Okay, so talk with somebody close with you, and we'll make this very short, 2 minutes. Okay, introduce yourself first, because you might not know each other. If you're way in the back.
I'm Heather. Kara. I think the like dramatic slope change is because it's going from like a bunch in A to none in B, so it's going to go more rapidly because it's tidal out, and then it like slows down as they become more in equilibrium. Yeah.
So if you imagine every second, like 5% of them switch over. When there's all in A and none in B, like 5% is a lot, but then when it's like more in B and less in A, some from B and less is coming out.
Yeah.
I don't know how to explain it.
No, I get it.
There's
Where it's
definitely
like,
like a way to do the math.
yeah. So because there's like nothing in there, then it's faster.
And once you have some in compartment 2, some of that is going to go back to compartment 1.
Yeah.
But overall more.
Kara,
Yes,
good to meet you. You emailed me about something.
I did.
Did we get that settled? You know what, I needed to, was it about the assignment? Or that might have been somebody else.
I didn't.
Okay.
Oh, I emailed you if you could record.
Somebody else had emailed me. I'm trying to be good about learning people's names.
Well, you helped me a lot last semester too, because you were in charge of labs, so. And Seth told me, he's like, you have to take 253. He's like, don't even take physiology, just take 253.
Cool. Yeah, that's good. Good. What's your name?
Heather.
Heather.
Yes.
Okay. What's your name? Griffin. Griffin. Okay. Good to meet you guys. Okay, that's enough of that. All right. Did you meet somebody new? Okay, good. Somebody tell me what's happening. Okay, number 2 here. How do you account for the changing slope of these lines? So what's happening here in somebody at A, we have one slope, but we have a positive and a negative slope, right? And at B, from B to C, we've got a slope that is getting smaller and smaller, right? More and more horizontal. What is happening that explains these changes in slope? Anybody come up with a good answer? Or did anybody's neighbor come up with a good answer they want? You want to tell me about? Yeah.
As more of the molecules move into the other compartment, they're essentially experiencing more resistance because then they can bump into the other molecules in there.
Okay. So that's a good way to describe it. The analogy was that these molecules moving from one side to the other are encountering more resistance, and that's kind of a good way to think about it, because these molecules are the idea here is that the rate at which these molecules move across the membrane is dependent upon 2 things, right? It's dependent not only on how much of its concentration is in compartment 1, but how much is in compartment 2, right? So that movement is going to be faster or slower depending on the gradient, okay? And that's kind of a word we use to describe the difference across those, across that membrane, okay? So what about at time C, what's happening here? we've already talked about this. But what's the word we use for what's happening here? Equilibrium, right? And what are those molecules doing? Are they doing nothing? No, they're exchanging across at equal rates, okay? So keep that in mind when we're talking about these concepts of diffusion. So I want to put this into mathematical terms. I don't want to, but I'm going to. And as you'll encounter in physiology, there's a lot of formulas, but I think what it comes down to is you need to understand, I said formulas, there's a guy leaving. See it. There's a relationship between variables, and that's kind of, and it's all very, very simple algebra. Okay, so when you see mathematical equations here, don't freak out. So one of the variables that matters, as was said by, is it Frankie?
Yes.
Cool. It's magic, right? The concentration difference, the idea that the movement across the membrane is going to depend on how much of each substance is in each of those compartments. Okay, so the concentration difference matters. Okay, so if we're thinking about the degree, the rate of diffusion, okay, what's the relationship between the rate of diffusion and the concentration difference? Is it a proportional relationship or an inversely proportional relationship? It's proportional, okay? So let me describe what that means. So when the concentration difference is high, you have a high rate of diffusion, okay? And when the concentration difference is low, there's very little difference, you have a low rate of diffusion, okay? And that's what we see here. So in the beginning, the difference, you've got lots in one side and hardly anything on the other side. The difference, concentration difference, is big, right? And so you get a big movement of those molecules, okay? And as time goes by, the difference gets smaller, and so the slope, the rate of change gets smaller, okay? So the concentration difference between the two compartments, okay? You can kind of think of this in terms of substances moving across a cell membrane, but just as likely we might be talking about a tissue, like the surface of your lungs, right, or the surface of your capillaries. The same principles apply, okay? The surface area plays a big role, okay? So the rate of diffusion, again, is dependent upon the surface area of the membrane, okay? So if we're talking about moving amino acids from the lining of your digestive tract into the cells of your digestive tract, right? So they're moving from the lumen, the cavity, into the cells. They're going to be passing through a cell membrane. And what's one specialization we have for that absorption is microvilli, right? So the cell itself has lots and lots of convolutions that help to maximize how much surface area is in contact. So is the surface area proportional to the rate of diffusion or inversely proportional?
Inverse.
So the more surface area, the what? More diffusion, the greater the rate of diffusion. These are proportional variables, okay? So the rate of diffusion is proportional to concentration difference. It's proportional to the surface area, okay? And again, we could be talking about a cell, we could be talking about the lining of your lungs, which is multicellular. Okay. And then the third variable is actually a bunch of things packed into one, okay? And this is permeability, okay? So that membrane that hypothetically separated those two chambers could have a high permeability to glucose, or it could have a low permeability to glucose, and that would impact its rate of diffusion, right? So again, it's a proportional variable, okay? And what this entails is, and you don't need to focus on all these things, but I just want to kind of run through them, and I want you to agree with me that it makes sense. Can you do that? You don't have to regurgitate this later, but the thickness of the membrane, okay? If you've got a really fat membrane, it's hard for things to diffuse through it, right? If you have a molecule that is not permeable to the membrane in the sense that it can't dissolve, in that substance, then it's hard, right? So if we have a molecule like a steroid, it's made of cholesterol. Can a steroid go through a lipid bilayer? Yeah, very easily. So steroids will very quickly move through cell membranes. They have a high rate of diffusion because they're soluble in the cell membrane. Okay? But a sodium ion, will a sodium ion pass through the lipid bilayer? No, it's charged. It's not going to be soluble in that lipid bilayer. Okay? So we call this the oil-water partition coefficient, meaning how many of those molecules would be in oil versus water. Okay. But conceptually, this is how easily does a substance move through a lipid bilayer. Okay. And then we've got other things like viscosity and the temperature. And these things don't really change in the body under most circumstances, but if you're interested in chemistry or physics, these things matter. Okay. So those three at the top, though, I want you to remember those. And the relationship is that we have the rate of diffusion, which is inexplicably given the variable J. I don't know why. This is why I sucked at physics. Why do you use that variable? I don't know. It doesn't make any sense. I got hung up on the letter. But we have the rate of diffusion, J, okay, is equal to the permeability times the surface area times the concentration difference, okay? And these are all multiplied by each other, which means that in terms of algebra, right, we're just talking about simple proportions, okay? All right, so those are the things that are going to matter when we talk about the respiratory system and gases moving into your body or through your cell membranes and so on. Okay. So we've kind of already talked about what can pass through a lipid bilayer, but let's get specific. Steroids and things made from cholesterol, right? What else can pass through a lipid bilayer?
Non-polar.
Small uncharged particles.
Uncharged particles, yeah. So anything, you can say anything that's small and uncharged, or even things that are moderately sized, but are made of hydrophobic molecules, can pass through. Okay. So what are some small uncharged molecules?
Water.
Water, kind of. Water, it's not charged, but it's polar, right? So water, Books sometimes say water. It's not quite that easy. What else is small and uncharged though? CO2, oxygen, right? So our gases can move through the cell membrane very, very easily, right? And that's great. There's no reason we'd want to stop that, right? So it makes sense. Water usually requires an aquaporin to move effectively through the membrane, but very small amount of water can get through there. Okay, so hydrophobic things, yes. Small, non-charged things, water, oxygen, carbon dioxide, maybe a little bit of water. Okay. What can't get through or has trouble getting through? Things that are charged and things that are polar. Okay, so maybe they don't have a charge, but